This is question 12 on maths from section 2 of the 2019 BMAT. So we're told that point M has coordinates 6, 3p minus 1, and point N has coordinates 1 minus p, 2, and that a line joining the 2 points has a gradient of minus 3 and a y-intercept of r. Therefore, based on this information, what is the value of r? So how should we go about this question? Well, the first instinct might be to do a plot diagram and draw out these points and this line. But if we think about that a bit more, that has limited use because 2 of these points are unknown, or 2 of these values, p and r, and it would actually be quite difficult to do a drawing without knowing so much information, because we'd have no idea of the scale, what's positive and what's negative. And so instead, maybe we should think about this as an algebraic problem and do it through the use of equations. So where we start in such a case? Well, the thing that links these 2 points together is this line that we're told about with a gradient of minus 3 and a y-intercept of r. So how do we represent this line formally as an equation? So if you use the classic y equals mx plus c with the gradient m and the y-intercept c, that would become y is minus 3x plus r. So we know this equation holds for all the points on this line, and we know both of these points are indeed on this line, so that is a good start. So what would be our next move? Well, we could set up 2 simultaneous equations for point M and point N using this line equation. So let's do just that. For point N, let's substitute in the appropriate values of x and y. So y is 3p minus 1, and that is equal to minus 3 times x. Minus 3 times 6 is minus 18, plus r. Then let's do the same for point N. Y value is 2, and that is equal to minus 3 times 1 minus p as our x value, again plus r. And this can maybe be tidied up a bit by expanding this bracket to become 2 equals minus 3 plus 3p plus r. So we have 2 simultaneous equations, and how can we use them to find out our value of r? Well, if we use this first equation, for example, to find an equation for p, and we substitute that into this, then that would allow us to eliminate p and get a numerical value for r. So let's do that. Let's make p the subject of equation n. So if we add 1 to both sides, that becomes minus 17 plus r on the right hand side. And if we divide both sides by 3 at the same time, that gives us this fraction for p here, r minus 17 over 3. Then if we substitute this into our tidied up equation for n, what does that give us? So we have 2 equals minus 3 plus 3p. 3 times p is just 3 times this fraction, so luckily the 3's cancel out to save us doing any particularly complex maths. So that gives us 3 times r minus 17 plus that extra r. So if we tidy this up, we should be able to find out a numerical value for r. So firstly, let's add the numbers from this side to get numbers on the left-hand side only. So 2 plus 3 would be 5. 5 plus 17 gives us 22 on the left-hand side. And we have our 2 r's on the right-hand side. And then we can see that simply by dividing both sides by 2, we can see that our value of r is 11. So we've been thorough to use all the information that's given to us to do an algebraic manipulation and use simultaneous equations to find out this value of r. And it turns out this was easier than sketching a diagram where we wouldn't have known where to put these points. So r equals 11 is our answer, and that corresponds to h.